ChatGPT-4 already has the vision feature. But what if we could make its eyes even more powerful in today's video? We're unveiling a game-changing tool called SoM. It takes ChatGPT-4's abilities to a whole new level. Stay tuned to see how Vision and SoM team up for an incredible AI experience. Consider this example. They asked ChatGPT Vision, "What is to the left of the right laptop?" It responded with a cup or a mug. Then they posed another question. "I want to find a seat near a window. Where can I sit?" The reply was, "You can sit in one of the two black chairs." However, using this new tool brings a significant change. They asked once more, "What is to the left of the right laptop?" This time, it answered correctly, "A lamp," labeled as 12. Similarly, they inquired, "I'd like to find a seat near a window. Where can I sit?" Once again, it answered accurately, "You can sit on the chair labeled as 7. Hi, I'm Danny, and in this video, I'll introduce you to this exciting new tool and guide you on how to use it. I've previously created a video about ChatGPT-4's new feature, and you can find the link to it at the end of this video or in the description. While creating that video, I came across instances where GPT Vision struggled to interpret images correctly, but now things are changing, so let's dive in. This tool is known as Set of Mark, abbreviated as SoM. It's closely related to Microsoft's open source projects, and it's been only a week since the project's GitHub page was created. You can find the link in the description. First, let's look at some sample tasks comparing ChatGPT-4 with and without SoM, and then I'll show you how to use this tool. In one instance, they provided an image to GPT Vision and asked, "What is on the right side of the left glass?" It answered, "On the right side of the left glass, there is a coffee machine," which was incorrect. However, using SoM, it correctly identified, "On the right side of the left glass, labeled as 25, is a jar filled with cookies, labeled as 10. Another user asked, "I am on a diet. What are the top things I should avoid eating?" GPT Vision with SoM provided precise suggestions, while the original one failed, even with hallucinated foods like soft drinks. For instance, a user asked, "What is in this dish?" GPT Vision couldn't provide a grounded answer with the original image, but with SoM prompting, GPT Vision not only listed the ingredients, but also associated them with specific regions. To access this tool, click on the link provided in the description, which will take you to the page. Scroll down to the SoM toolbox header. This is the toolbox, and I'll explain all its components. Here, you can upload an image you wish to label, or if you'd like to test it, select one of the example images. I'm selecting the second one. In the granularity section, you can select a number from 1 to 3, which determines the model and segmentation level. For instance, setting the number to 1 employs the same model and results in less detailed labeling, focusing on a more limited set of objects in the image. Conversely, choosing the highest number provides more detailed labeling, expanding to encompass a broader range of objects within the image. In annotation mode, you can select whether the image should be labeled with masks, boxes, or both, and whether it should include a mark. In mark mode, you can choose to mark with numbers or alphabet. Mask alpha adjusts the intensity or visibility of the mask's color. There are 2 segmentation modes. I'll test all these settings with automatic mode to demonstrate how they work before explaining and testing the second mode. I've set the granularity to a higher value and used other settings by default. As you can see, it labels more objects and marks them with numbers. Now I've set annotation mode to box and mark mode to alphabet, and I've set the granularity to a lower value. This results in labeling with alphabet marks instead of numbers and fewer objects. In the last demonstration of automatic mode, I've set the mask alpha to the highest value and unchecked the mark, then clicked on Run. The result doesn't include any marks, and the masked color visibility is at its maximum. Now I'll change the segmentation mode to interactive. When you select this mode, you can choose which parts of the image to tag. I choose the parts, such as some fruits, fruit basket, table, wall, and the curtain. As you can see, the image has been labeled as desired. There are buttons here to change the brush size, increase or decrease it, an undo button, and a clear button. You can click on the download button to obtain your labeled image, which you can then use in ChatGPT for vision. Now, with a labeled image, you can interact with GPT Vision and ask questions about specific parts of the image, giving it a deeper understanding. For example, a user asked, "I have labeled a bright numeric ID at the center for each visual object in the image. Please tell me the IDs for the laptop behind the beer bottle and the laptop turned on." GPT Vision responded with the IDs for the items you've mentioned: the laptop behind the beer bottle, 6, and the laptop turned on, 2. In another example, a user inquired, "I have labeled objects in the image. Please enumerate their names." GPT Vision replied, "Number 1 is a person, 2 is another person, 3 is yet another person, 4 is a surfboard, and 5 is a handbag." You can even use it for video segmentation. A user provided two images from the same video. The first image represents the first frame, and the second image is from a later frame. Two objects are labeled with 1 and 2. User asked, "Can you track these two objects in the second image?" It replied correctly, stating, "The object labeled with 1 is most similar to the object labeled with 2, boxer in red headgear, and the object labeled with 2 is most similar to the object labeled with 1, boxer in blue." It may also assist in solving CAPTCHA puzzles, but I haven't showcased this particular example as a successful task because I believe it still missed some squares. But here's another example, where a user provided an overhead view of his house and asked, "I am a bit hungry. Where can I find some food?" It correctly replied, "You should head to the kitchen area, which is labeled with the number 10. Or when asked, "Where should I sit to eat if I find some food from 10? It responded, "The dining area labeled with the number 14. It appears to have a dining table and chairs." The user asked a few more questions and received correct responses. Cross-image referencing is another cool task that we can perform. A user used two labeled images and asked, "What are the common objects in the two images?" GPT Vision, with the help of SoM, replied, "The common objects in the two images are a man and an iron, and clothes being ironed," mentioning the corresponding ID for each element. There's another way to run this tool, one of them being to run it locally on your system or on Google Colab. This GitHub page provides a Colab link, which I've included in the description. However, please note that this is a non-official implementation of the set of Mark tool. I run the Colab to give it a try, as mentioned here. You need to ensure that you have access to a GPU. To do this, navigate to Edit, then Notebook Settings and Hardware Accelerator and set it to GPU, and then click Save. Click the play button in order to run all 7 cells. Next, run the 8th cell to create the data folder and upload the image you want into this folder. And then run the 9th cell before executing the next cell. Go to the data folder. Click on the 3 dots next to the image you uploaded and copy the full name of the image with its extension. Then replace it in this field. Now, run the rest of the cells and wait for the result. It downloads the SoM model by default. It's like putting 2.5 to 3 in the granularity setting in the toolbox that we discussed before. I didn't delve deeply into this, but it appears that we have limited control over the settings, making it less user-friendly compared to the previous toolbox. Nevertheless, it gets the job done efficiently. This is the result, and it did the job very well. But I prefer using the previous toolbox or installing it locally. Though I haven't tested it myself yet, I'd like to share one more interesting use case. From this GitHub page, they've introduced a tool that combines GPT vision and the SoM to connect the user with any graphic interface easily. It functions as a multimodal AI assistant. In one instance, a user asks GPT vision to find and play a random song for them. The assistant searches for a random song on Google, finds a website, and plays the song. The significance of SoM here lies in labeling the environment for interaction, allowing GPT vision to navigate it effortlessly. To wrap up, using this tool adds a visual grounding capability to ChatGPT vision, enabling it to provide grounded answers with original images. I'm interested to know your opinions and experiences with this tool. Have you used it? And how has it enhanced your user experience with ChatGPT vision? Please share your thoughts in the comment section. We've reached the end of our video. What's next? Here's what to do next. Don't miss the opportunity to explore an exciting, new and unlimited AI image generator that could serve as a Midjourney alternative also. Learn how this AI is about to revolutionize humanity.